Hello, welcome to your video on exponents. This is an introduction to exponents, something you've obviously seen many times, but let's take a look at the rules and recap the things we'll be using in this larger unit. Okay, to begin, this is obviously a big idea. Exponents are all around us in our mathematical world. Let's take a look. Exponents are also known as powers or indices, and they are a quick way of writing repeated multiplication. For example, instead of writing 2 times 2 times 2 times 2, we can just write 2 to the fourth power. So it's just like an abbreviation. So here we have, this is called the base. This number here is called the exponent or the index. And we can say 2 to the fourth power or 2 to the power of 4. Let's take some notes while we watch this. There's some key rules of exponents we'll look at. Let's jot them all down. So these are called the laws of exponents, or basically the main rules that allow us to work with exponents. Let's take a look. First one, multiplying exponential expressions. Let's say we had x squared times x to the fifth. Often it helps to write exponents in expanded form in order to see where the rules come from. So that expanded form is x times x, and this one here expanded is x times x times x, all those 5x's multiplied. So now we have 2x's here, 5 here, that's all being multiplied. So we have 7x's being multiplied. That means we have x to the 7th power. So we can draw our main rule about multiplication from that. So what happens when you have two same bases with exponents and you multiply them? What does that equal? From here we can see when you multiply those, you add the exponents to get the new number. Okay, don't multiply those, you add them. So adding is the rule there. Okay, let's look at another thing. We have dividing exponential expressions. Let's say we begin with this one. We have x multiplied by itself 5 times on top and 3 times on the bottom. So here's the expanded form. Then we can cancel common terms on the top and bottom, or the numerator and denominator. Cancel those three, we're left with 2x's. That means we're left with x times x, which is x squared. Looking at that another way, we have basically we can say that we have the top number, the bottom number, we can subtract those to get x squared, and we can see that x squared was here. So we take that number, subtract, and we get our value there. And basically another way students look at that is, well, I have 5x's here, 3 here, I have 2 extra ones there, so there must be 2 on top. And the rule there then, based on what we see here, is when you have 2 common bases and division, what do you do with the exponents? Well, that equals a to the power m minus n. So just like we saw here, you subtract those two values to get your answer. Okay, so next part we have is exponents with the power 0. This is an interesting concept in exponent. Let's look at it this way. Let's begin with two equal exponential expressions divided here, and we know that then if we expand that, we have 4x's there, 4 there. Cancel all those. And if you cancel all those, you're going to be left with 1 over 1, because each of these becomes 1. So 1 over 1, which is 1. So now we know that that equals 1. And that makes sense, because something divided by itself will be 1. Let's look at it a different way. We learned the rule about division of exponents. So when you divide these two expressions, you can actually subtract that minus that. So we're doing that subtraction here, and that equals x to 0. So since that equals 1, and this also equals x to 0, that means that x to 0 must be equal to 1. So that's an important rule about exponents. Anything to the power 0 is going to be 1, and it's because of what we've shown here. So that rule is, if you have a base to the power 0, it is going to equal 1. And that only works when the base is not 0. Okay, let's look at the next one here. We have negative exponents. Okay, negative exponents, let's begin here. So let's say we have x cubed over x to the fifth. Now we have 3x's on top, 5 on the bottom. So that's the opposite of what we had before. There are fewer on the top than the bottom. Cancel like terms, and we're left with 2x's, but this time the x's are in the denominator. So we have 1 on top, those 2x's in the denominator, and that makes 1 over x squared. So that has become 1 over x squared, and that makes sense again because we have 3x's here, 5 here, there are 2 additional x's here, therefore there's our x squared in the denominator. Now let's look at it a different way again. We have division, and remember the division rule is we're going to subtract those two exponents. So that equals x to the power 3 minus 5, and that gives us negative 2. So again, if this equals this, but this also equals this, then these two things must be equal. So x to the negative second power must be equal to 1 over x squared. That's an important rule of exponents there. When you see the negative exponent, you can just bring that whole term to the denominator and make it a positive. So the rule is if you have this base with a negative exponent, you can rewrite it as 1 over a to the positive exponent there. Okay, with that, one more look at negative exponents. So this is one way to kind of derive where this rule comes from, and here's another way. Let's say we have x to the negative p. That is the same as x to the 0 minus p. Now use the rule about division and subtraction of exponents here. What would that look like? Well, when you have subtraction like that, means we have a fraction like that in the beginning, because then you subtract that minus that to get there, right? So now that you have this, x to 0 is 1, so that tells us that this is equal to this. And that's what we saw in the previous slide, that when you have a negative exponent, you can rewrite it with the 1 over xp. So that just further verifies this rule. When you have the negative exponent, it just can be rewritten with it like this. Okay, so with that, we're going to look at raising a power to a power. So we have an exponent, but within the parentheses, another exponent out here. So that means we have 3 of those, right? We have x squared, 3 of them. So x squared times x squared times x squared. Now using the multiplication rule, we know those exponents will add, and then we get x to the 6th. So now what is the connection between this and this? So what's the rule? What's the rule you see there? Hopefully you figured out that it must be m times n, right? You multiply these two numbers when you have the parentheses to get your simplified exponential expression. So multiply these two right here. Okay, with that, you're ready for these three. Try question A. Check your work here. Now try question B. Alright, check your work here. In B there was division, so you divided the numbers to get 6, then you divided a to the 7th and a cubed. There are more a's on top, there are 4 more a's on top, so there's a to the 4th. And here when you look at the last c's here, there are 3 extra c's in the denominator, so you could write it as c cubed in the denominator, or you could use the rule about subtracting those 2 minus 5 and get the negative 3. And then that goes to the bottom like that. Try C. Okay, there's the answer for C. In C, be careful when you have an exponent outside the parentheses, that exponent applies to every piece in here. So that 3 will go on the 4. You can see negative 4 to the 3rd power. It will also go on this P, which is now P to the 3rd, and it will also apply to this Q, which becomes Q to the 6th. Alright, check your work carefully. Now let's talk about fractional exponents. So let's change it a little bit. As you know, when you have root of 16 times root of 16, that is the same as 4 times 4, because the square root of 16 is 4. So 4 times 4 makes 16. So there's a connection here between what we began with and this answer here. So can you make a rule of that? If you had root x times root x, just like we had root 16 times root 16, what would that equal? That would equal x. Just like here we had those two roots multiplied, and the answer in the end was 16 was one of the numbers inside the root, right? So if you have two equal roots, the answer just ends up being the thing inside the roots, like that, x. Okay, now let's look at this. Let's say we had x to the half power times x to the half power. Well, by the rule of multiplication, when we multiply it, you can add the exponents. So x to the power half plus half, and that means x, because half plus half is 1. So this is like x to the 1, or x. So now we notice that x equals this, but x also equals this. So I'm going to write those out again. Here's one statement for x, and here's another one. X to the half times x to the half also works out to be x. So that equals x, that equals x. That means that these two things must be equal. And if those two things are equal, that tells you that root of x must be equal to x to the half, because each of these pieces must be the same. So that's an important rule. when you see a square root, it can be written as x to the 1/2. Okay, key rule there. And here's a little bit more about that. So here's x to the half, which we just saw equals the square root of x. But also, x to the fourth equals fourth root of x. So the way that works is this number in the bottom of this fraction in the exponent is the number that goes right here. And as you know, a square root, there can be a 2 written here, but it's not necessary. We know that means the square root, and that's what the 2 would be. But here we have a 4 in the denominator, so that 4 ends up being here. So it's this fourth root of x. And then another one, we have x to the 1/9 power, and that equals the 9th root of x. So I think you can see the pattern clearly, and let's make a rule. So if you have a to the 1/n power, that is equal to the nth root of a. Okay, a little bit more about fractional exponents. Let's say we had this. So this one always had 1 in the numerator, but now we can have other numbers in the numerator. So this one becomes this. Okay, x cubed, that is like, imagine like that's the upper exponent. This 2, just like here, was the bottom of a fraction, so that 2 in the bottom of the fraction ends up being the number that goes here. And we don't have to write the 2 there when we have square root, so there's a 2 there. Another way to write this is like this. So that 3, which is the exponent, can be either inside or outside the root. It doesn't matter. It means the same thing. Here's another example. We have x to 7/4. That time 4 is the denominator, so 4 goes here. And the 7 is our power, so it goes here and then here, either inside or outside. So the general rule, when you have m/n, that becomes a to the m, and the n here is the root, or the m can go on the outside. Okay, let's try this. Try a. Okay, for a, check your work. So that, using the rules of roots we just learned, that can change into that, which becomes this, because the third root of 8 is 2, squared is 4. Try b. Okay, that written in exponential form, well, maybe you just look at it and jump right to there. Here it shows some steps along the way, but there's the answer there. Okay, one last thing in this video is we're going to look at solving exponential equations. Something we looked at in the previous year, but let's see if we can jog your memory. So let's say we have these two exponential equations. And already, if you're thinking back to what we've done in the past, maybe you're thinking logarithms already. But remember, before using logs, which we'll get to here soon, but before logs, we can just look at, can we make a common base? I see a 3 here, so can I make a 27 also a 3? The answer to that is yes, we can. So here's our 3 to the x plus 2, and 27 is actually 3 to the third power. So now that we have a common base, if we have something to some power and something to some power, and that these two numbers are the same, then the two exponents must be equal. So x plus 2 must equal 3, because it's the only way that we'll have a true expression here. And if you solve that, you get x equals 1. So try that approach in B now. Can you make a common base here? Is a 4 already the common base, or do you need to change both of them this time? Well, in this case, you should change both. The 4 here can become 2 squared, and the 8 here can become 2 cubed. So notice I have 2 squared and then the same power as I had there. And notice this 8 is now 2 cubed, and then that power is the same here. So this, by the rule of parentheses and exponents, we're going to multiply 2 times this, and over here we're going to do 3 times that. And remember to do 2 times all of this. So you should have now 2 to the power 4x plus 2 when that was multiplied, and equals 2 to the power 3x plus 6 when this was multiplied. And again, we have the same situation as here. We have a common base, 2 and 2. So if this 2 to some power equals 2 to some power here, then those two powers must be equal. So 4x plus 2 equals 3x plus 6. And if you work that out, you get x equals 4. Okay, so that was a recap of a bunch of rules of exponents or indices, and then we ended with this solving of exponential equations. So make sure you have all those rules well practiced, and see you tomorrow. I will do some more work with that.